Inconsistencies. All right, start every video like that. Okay. All right, and today is the day. Oh, by the way, we do have a quiz. Oh, the other teachers are doing a quizzes right now with their students. Do you want to do a quizzes right now for a grade? Do you want to do it now by yourself or tomorrow with live and I yell at you when you get them wrong? You want to do that? Is that more fun? You like being judged, don't you? That's good. I'm glad I do that. Okay, so we'll do that. But also, it's a teaching thing too. So it is going to be taken for a grade though, because the others are doing that. And but me doing it live should help you on later questions if you screwed up the previous one. I don't really care. It's 5% of your grade, that homework category. They just want evidence for yourself as well. Like, hey, I'm not ready. I need to do something different. If I'm not doing well on those formatives, is what we call them. But Tuesday is a real deal. And I guess it's important. I'm kind of talking about this on the video if someone is absent. I think I did have someone absent last hour. Um, it's a quiz. So they're kind of weird with the points. I kind of like doing quizzes at 50 and tests 100. They're just whatever the points add up to become, that's what they're doing. But our last one was like 72, right? Right. 72 points. Just left it as that. The one previous to that was like 30s, somewhere in the 30s. So I'm imagining on Tuesday it's going to be one of those in the 30s because it's a quiz. So we're talking between 30 and 50 on quizzes. Not and it is a quizzes tomorrow. That's a accident there. And then the real no, sorry. That's not what I'm talking about. Sorry. Tuesday's real quiz. It's probably going to be between 30 and 50. Then a future test will probably be between 50 and 100. I don't know. Wherever the points line up. They'll be relatively close in weighting, so it doesn't really matter that much. Okay, so now I'm doing this. Yoink. You read and you graph. You don't sit there and say, "How do I do this? I can't read. Can you read for me, Mr. Samulus?" Okay, and then y equals 3, x minus 3. Sorry. Am I frozen? Oh, it's not on the TV. Whoops. Knew I heard some clamoring. Boom. Okay, right? You better have that. If you don't have that, you're a bum. Okay, because you tell me you can't graph a line. Okay, so I got that. X intercepts, please. Well, this tells me everything. I actually don't need anything after this. One, two, three, four. Because this is the only way this could shake out then. This would have to go from here to here and here to down here. It'd be nice if they gave us a Y intercept. They didn't. Oh well. There's definitely a Y intercept here though. Somewhere some way, shape, or form. But fine, they give us this. Two left. When I'm left of two, there is no way that could be down there. It would have to be up here. Okay, so this actually doesn't even, this could not contradict what, this would have to be infinity for that first one. Because if it was down here, then it would go against like what's happening with this asymptote. So even without those limits, this is absolutely what would have to happen. Approach and approach. This is why I wish they said there was a y-intercept. It would add to the, meaning of this graph. And then this would have to approach that asymptote and then approach that one. So that's what we got with that picture, even without these last two things. They could not contradict that, but it does say that. So to left is infinity, to right is negative infinity. I'm just kind of drawing a point that's as far as I possibly can make it on the grid provided. Input, say it. That's what that is. -3, 6. Oh, and that is a point. That is important. I do have an oblique asymptote. Watch this. So that's 0, 0 is the y-intercept. And then fall 3, run 2. But you know what? I got to find out where that point is compared to this asymptote. So I'm going to rise 3 and go left 2. Rise 3 and go left 2. So that is to the right, I guess, what we could say, of that slant asymptote. So this is good stuff. Do people know how to graph lines? It's interesting. Oh, some of my A-Bers. I know they can't graph a line. 2 plus 2 is 6. I don't know what's going on in that class. I'm just kidding. Do I rip on the A-Bers all the time in here? We just took a quiz and it just didn't go as well as it should. She had a lot of people get 100 and some people are bamboozled in that class. What's going on? Can't memorize. I don't know what's happening. -1 comma 0, that tells me everything. Whole at 0, -1, I will get that. 0 comma -1. Okay. So this tells me everything. The graph must be controlled by the asymptotes. So I must have this connected to this and then through to that asymptote, then a little bit of like a U-ish kind of thing, smooth and curved. Try to make it curved. I don't know how high it goes. I don't have an equation to even check that on the graphing calculator. So we're just making sketches and just denoting the fact that the graph is controlled by these asymptotes. So that's why they have to end the way that they do with the given information. So that gives you an idea of how we're going to graph by hand coming up, right? Really. Okay, got it? Now I'll give you a minute on this one. Is anyone done with this one? Okay, try to produce your own. Are you done? You're done. Are you done? You done? No, just looking around. 1 tile, 2 tiles, 3 tiles. Anyone know how many tiles are in this room? Some of my A-Bers do, because that's all they do all day. Do you have any friends in that class? Do you tell them what I do? All right. Huh? First, second, and seventh. They know? They're driving me nuts. They act like it's so hard, and it's like, can you memorize? Come on. I don't know. I know I feel bad now, I guess, but still, it's just like I feel like I'm handing them all the information, and we're doing it over and over and over again. And 24 points, 12. Vertical asymptote at x equals 2. Let's keep plugging away is all we can do, I guess. Don't give up. That includes me. That's why I have that poster. I read that poster all the time to myself. Never give in. Never give in. Never, 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 never. No x-intercept. That's wild. Oh, wrong. What's that 0 comma 1? What's that 0 comma 1? A whole. Okay. And then no x-intercept. We used to do so no x-intercept, nothing to do there. Oh, okay. Limit of f of x as x approaches to right. I screwed this up in 4th hour. I forgot I put this point up here. So we're ending really high. That's what that means there. That's interesting. Oh, by the way, no x-intercept. Oh, no, not that. Not only no x-intercept, but these limits. As I go to infinity and negative infinity, the graph approaches 0. That means I have a horizontal asymptotes at y equals 0. Those are coincide with each other. Those are correct things. Okay, I got it. This side has to be here, whole, and then go to there. And then the other side, you know what I did the other hour? I forgot that this point was up there. And I said, usually it goes alternating and it usually goes like that. But it could be up here. There are unique times that could happen. So you could do one or the other. And then I started to move on and someone raised their hand. And I completely and totally forgot about that limit. It is absolutely up here. All right. And the graph has to, and it doesn't matter where this is, how close, you don't know. Okay. It's a sketch, how close that gets. But what you do know is it's got to behave to these asymptotes like that. That's what you do know. So I feel free to share my mistake from 4th hour and then someone caught me. So I didn't do it on purpose. I did it on accident, but sometimes it's good to see that. Don't lose your stuff. You know what's going on here. You can read. Doesn't this look familiar here? Anyone remember this from yesterday? I wonder if what they did last year was, hey, let's pull that part and spend just a quick Wednesday on that and just talk about it. So we already got that. I didn't feel like trying to get that out and then redoing the homework notes or the notes, whatever. And then this is fine. I don't think I'm going to identify them by words. Like identify the discontinuities and tell which each type is. This is what I like. But we're going to do this: equation of verticals, any holes, equations of end behaviors, whether they're horizontal or oblique, x and y intercepts. Take out any other essential points for graph behavior. Input, say it. So you're going to be no graphing calculator on this. So here's how you survive. Number one, this is what you got to do. Good foilers. Now be careful on -6 and -5. Could be 6 and 1 or 2 and 3. Which numbers is it? 6, 1, 2, 3. Which ones? 6, 1. Who's negative besides your teacher? 6. All right, and then here's I just go in order. First thing I find is x-intercepts, then y-intercepts, then and then in this case, when we go to the next one, vertical asymptotes, vert-acies. When I say I have a vert-acy, aren't I identifying the discontinuity, right? Okay, and you could, if you want to put this is a discontinuity. I don't care, all right? If there's a hole, I'll write it. Horizontal asymptotes are not discontinuities. They are end behavior. So end behavior asymptotes, that's what this is, got it? I don't think we need to do all that. Hey, by the way, remember when I highlighted? Oh, no. What's the x-intercept? What is the x-intercept? I don't have any x's up there. So what's the x-intercept? None. None is different than 0. Okay, when you say 0, are you meaning none? Better say none, because 0 is a number. All right, right? Hey, and then y-intercept. Remember I did this? Yoink. What's the y-intercept? 0, comma. What's the answer to that? 0, comma 1/3. And then we'll go over and graph these when we're done figuring. And then vertical asymptotes. What are those? Yoink. X equals 6. X equals -1. Oh, yeah. And then horizontal asymptote. Oh, no. What is the horizontal asymptote? What's the degree of the numerator, by the way? It's error. So what is it? 0. So what's the horizontal asymptote by default? Oh, no. Are you like my A-Bers that can't memorize? Y equals what? 0. It's because when I throw in a big number, 0 over 100 squared is 0. I'm sorry, -2 is up at the top. But -2 over 100 squared is essentially 0. It's so small. And then same thing when I plug in a -100. I don't care about the other parts because they're insignificant as I plug in large numbers. Am I missing anything else? I don't think so. So it's x-intercepts, y-intercepts, vertical, horizontal, or slant asymptotes. Mark them 0, comma 1/3. And then you'll see that only a certain couple things could happen, or one thing could happen. So I have this. Whoops. And then this is what I did with the other hour, but I don't really need to do this. I know what's going on. There are no x-intercepts, and I have this point. The graph must behave to this asymptote. So I don't even think I did a chart of values in fourth hour with this. Yeah, maybe I did. Because you know what? We just had a question where the other graph was up here. But listen, wherever there's a vertical asymptote, there's always a graph to the left and to the right of it. So I got something. It's either up here or down there. And I got to find out where that is. And I don't have a graphing calculator. So input, say it. The only value I'm going to plug in is 7. That is right after this. And all I have to determine is it above or below? Did I screw up again? What did I do? I do have x equals -1. Oh, I didn't draw it. Oh my gosh. Oh, this is so embarrassing. Oh, I never was good at teaching. I knew it. I knew it. I knew it. I've been saying it all year. That's my naysayers. Do you know I have a fake Twitter account? An evil student in 2000, I think 13 or 14, illegally took my picture while I was sitting up here, posted that picture on the Twitter account as if it was mine, and then started a Twitter account. And it was all these sayings being put in there. Probably could still find it at this point. So that's why I know I have naysayers. All the people that, they hide in their little basements and put their little comments and, can't do it face to face. That explains the internet, by the way. Little cowards like going on, yeah, I hate this little thing, and then they type it on there. Or is it like this? Okay. Huh? I think I knew who it was. Yeah. I think it's too late to get them since they already graduated. All right. So you're right. Thank you. Oh no, input, say it. So I have to do another set of inputs. I have to go to -2. Why -2? All I need to assess is where am I? Am I above or below? So now I got this. I'm either here or am I either here? And they're not circle graphs. I'm just denoting a location. So you got to be able to do this without a graphing calculator. Actually, maybe even without a calculator. But all you have to do is positive or negative. That's all you have to assure yourself of. So what's down on the bottom? Sorry, that's squared, right? What's -5 times -2? Bless you. 10. What's -2 squared? So isn't this -2/8, right? But I don't really care about it. All I need to know is it's negative. So that means above or below that horizontal asymptote. Below. But I'll go ahead and write it. So -2 comma a fourth negative. Okay, that tells me everything because the graph is controlled. Stupid. And then controlled by the asymptotes. I guess I could turn that off. There's another upgrade. What are upgrades, by the way? I told you this, right? Downgrades in this program. Anyway, and then here, do you see any other x-intercepts here? Are there any x-intercepts there? So absolutely, positively, what has to happen is this. This can't go down from there. This has to go to the left, go up because there's no x-intercept here. And then this has got to like stay above and then go up here because there's no x-intercept. So it's almost like a parabola, but not. It's really bad to call it that. And I could prove it. 1, 2, 3. I could plug in 3, input, say it's. Okay, and then I got to see this. So then it's -2 over 3 squared, which is 9, minus 15, minus 6. But that's a negative. But what's a negative over a negative? Positive. That's all I really care about. And it is actually really small. -21, -2 over -12. Is that right? Which is 1/6. Good. Someone shook their head. And then 7. Why 7? Because I want to see where it's at above or below over here. I'm going to guess below because usually that is how it works. Above, below, above, it kind of alternates. So -2 over 7 squared is 49. 7 times 5 is 35. Minus 6. What's the bottom, positive or negative? What's the bottom, positive or negative? Positive. What's negative over positive? Negative. So I know I'm a below, so that's all I need. And then demonstrate the shape there. Okay. Now I'm going to cover this now because some people did seem like, or maybe I haven't. The domain is all real numbers except these interruptions. The graph is undefined at -1 because you get a 0 in the denominator, and also undefined at 6. Sorry, I had 7 in my head from the chart. 6, I know I said 6, but 7, my brain did 2 different things there. And that's the domain. Now the range, I am going to tackle this because they do it later. We should be able to do it now, but you don't have sufficient information. Here's what you're going to have to do for the range. The range, you would have to go to your graphing calculator and find the what of this curve. Minimum. So you'd have to go to the graphing calculator and find that minimum, and I'll put calculator there. So I'd have to type this in, the full function, blank over blank, and then find that minimum. And then here's the range. I'll do this in red, but then I'll put blue for this. It is negative infinity all the way up to 0. Listen, horizontal asymptotes can be crossed. It is possible in the middle, but this one is not. So since it's not, 0 is not a range value. Then union that from 0, wrong. Minimum, that's the next Y value, whatever that min is right there. Whatever that Y value is, that's the lowest Y value on that particular part. And then it arrows up to infinity, so it's infinity. Okay, so again, one more time, you'd have to go to your calculator and find that. That is not something you'd be able to do without. Got it? Does that make sense? Yes? Yes? Okay, so you got to be able to analyze range from a picture. I'll just do these 2 more, and you know what? You have enough to try on your homework, okay? So after that, I'm going to leave you alone. What do you want? Yes. You know what? It's technically a bracket, although it's more than likely going to be a non-terminating, non-repeating decimal, which is kind of weird. So once you round that, it's almost illegal to use a bracket. I always felt, but use a bracket because you're including that Y value. Oh, that was nice. Students randomly shaking hands in the middle of notes. Okay. Anyway, congratulations. You got that example done. Is that what that was? Huh?
I thought we were done.
Heck no. You go on and on and on. It's so boring. I'm so droll today. I just have low energy. Anyone ever have that? X-intercepts. I'm not highlighting. I'm too tired. 0, 0. Fine. You know what? You kids. Right? And then I'm not highlighting anymore. I was worried about people forget that X is a 0, 0. And then -1, 0. No highlighting. Y-intercept. What is the y-intercept? Oh no. This is how I do the y-intercept. 0 plus 0 over. Okay, that's actually okay. I don't know what I was thinking of. What's the y-intercept? Oh, I'm a fool. What's the y-intercept? Well, if the x-intercept 0, 0, that's also a y-intercept. I'm a fool. Okay, I think I was thinking of another question. All right, you don't have to do this now or later, whatever. Okay, got that. All right, and then vertical asymptotes, we definitely got that. Vertices, x equals 1. I guess we could do these as we go. Sometimes I forget, so I like finding them all first, then making sure I graph them all, but whatever. Hey, what kind of asymptote do I have? What kind of asymptote do I have? You could say the word oblique. Someone said that nicely last hour. Slants are oblique, and you're right. An oblique asymptote is anything not horizontal. Okay, and they could be squared, cubic. I don't think we ran into that. I think I showed an example of that. All right, so I synthetically divide by 1. By the way, for full synthetic division, the constant is 0, so we would need that space if I had to write the remainder, but I don't. 3, 1 times 3 is 3, 1 times 6 is 6, but I don't need the remainder. So here's the slant asymptote. Y equals 3x plus 6. Up 6, 1, 2, 3, 4, 5, 6. And then fall 3, because I go off the screen, and then run 1. Fall 3, and then run 1. Okay, I got it. And then here's the thing. I'm off the scale here, so I got to be careful to not miss another part of my graph. And I don't really think I have to input output on this one, because look at this picture. I already have these 2 points, so I know what's got to happen. That's got to come down and go to that asymptote, do a little loop up here, and then come and hit that x-intercept and go to that. So, okay, I do have to do one input output, but I'm pretty sure it's up here. It usually does alternate. Like it's not below, it's above. It usually, this is below the slant and then this is above. But in the bell work or whatever, we did have one where this can happen. This can happen. So we got to be careful. Watch out. Mr. Samuel is steering you wrong. All right. So we are going to input 2. So kind of look at it as a chart of values. Any value you need, if you don't have a graphing calculator, just check it. 2 squared is 4. 4 times 3 is 12. 12, 2 times 3 is 6. And then 2 minus 1 is, there you go, 2 comma 18. That's way up here. So that just tells me I'm in between these. So just tell me that you have something shaped like that somewhere way up there. Don't change your scale. Just, we have a little sketch here. Got it? Isn't this easy? Okay, one more. Why? Because then we got one more. And then we will state the domain and range on this one. What's the range on this one? I would have to find the what, every one of this little curve, max. And then what would I have to find of this little curve? The minimum. So it's negative infinity to that max, whatever that y value is, union that with whatever that min is to positive infinity. Domain, there's only one interruption, the vertical asymptote. Got it? Okay, so that's not too bad. Good FOILers, anyone? Careful. Not everything is factorable. I find out if it is, if there is something that multiplies to negative 6 and adds to 5. Does something multiply to negative 6 and add to 5? But then I get worried. People that don't know factoring put those numbers into parentheses. All I did is determine it works. And then, okay, I need 5x. So what goes there? What do you think goes there? 1 and 3, right? So which one is it, 1 or 3? 3. And then that's 1. And then who's negative besides your teacher? I went off on some rants yesterday, didn't I? Do I like the Kardashians or not? Heck no. Useless billionaires for no reason whatsoever. Okay, 2x. And then, what do we have, everyone? What do we have? A whole. Okay, so I do want to cross that off because that's not an x-intercept. Now we'll start flying. X-intercept, 1/2 comma 0. Y-intercept. Oh no. What's the y-intercept when -3 over 0? Oh no. What do we get for a y-intercept? None. So we don't cross the y-axis. All right. That's a good way of conceptually thinking about y-intercepts, plugging in 0 for x. I cover them with my hand if it was a quiz or a test. Vertices, we certainly have, and don't screw this up. It is x equals 0. I'm going to highlight that because this is a screw up, both numerator and denominator. When an x is just floating there, students tend to ignore it. We don't have a y-intercept, but we do have a horizontal asymptote? Let's do that. What's horizontal asymptote? Oh my gosh. This is AB. I can't memorize the rules. What's the horizontal asymptote? Y equals what? 1. 2 over 2. Simple. They are driving me nuts. Just flushing points down the toilet is what I really am sad about. I don't know what I can do except reteach, over and over and over and over. You know what? I know exactly what's going on here, but I'll prove it. But I got to get that whole too. Actually, that whole is going to give me some information. So the whole comes from -3, the 0 of the factor that cancels. Save myself there with my wording. And then you plug it into the leftover input, say it. That's just the leftover function after the canceling. So I did f of -3 into this only, and that should be your quick sketch. Isn't that -7 over -6? 7/6, which is just above 1. Got it. I have everything I need for this picture. I don't need to input, output anything else on my chart. I know this has to happen and then it stays above. And then I already have an x-intercept here, so this goes to that and then that. And make sure you keep this above this little part here. I get goofballs that do this. They hit this and then they go like this or something. I don't know. They just draw something weird, and it just doesn't even make sense. Okay. It hits that x-axis and goes above and stays above. Got it? Okay, and then I screwed up my domain for a second on with the class, and it does say find domain and range. Domain is negative infinity to infinity, excluding these values that gave me a 0 on the denominator, which is -3, naughty. And then the vertical asymptote gives me 0 in the denominator, which does not produce an output. And then the range, this one's very doable without a graphing calculator. So all the way down here, all the way up to this boundary. Listen, be careful. Horizontal asymptotes can be crossed in the middle. It could happen. All right. But anyway, so it'd be negative infinity to 1. The horizontal asymptote is not crossed. But then we also have this other range issue, this hole. This graph does infinitely go below this hole for a y value, so that y value is not covered. And that y value is 7/6. So holes also kill that range. But you know what? For movie purposes, I'm going to show you what happens a lot of times with graphs. A lot of times this could happen. I have a I have a vertical asymptote here, a vertical asymptote here, and then let's say a horizontal asymptote here. My question on this one is, what is the range? Hold on. I got this. Let's say I got this. And then in the middle, I get one of these, which we have seen before. I get that picture. What's the range of that picture? 3, 2, 1. All you have to do is look at this part. What's the range? All real numbers. So this is because we have issues over here and over here. This is the whole picture, all 3 parts together, and all the y values are covered. But then be careful. If I do have a hole in one of these, then that's an interruption. No, it isn't. I'm a liar. Just because this is a hole here, do you see that y value being covered over there, right? So that would still be all real numbers. So be careful on that. You got to look at all 3 parts and something like that. I think that's a good thing to go over and end with. Okay, move around if you want, work with someone. That's what the U-Try is. Just do your dang homework, which is a lot of it. Just trying to do what they're doing.